As always, if you haven't done so yet, make sure that you pause the video and try to answer the question on your own first before listening on. We can go ahead and draw a quick picture of the scenario just to get some clarity. So we have drawn a plate that has a positive charge and then another plate that is parallel to it with a negative charge. And it turns out that in that scenario there are electric field lines that point from the positive plate to the negative plate. Those are shown by these orange colored lines. And then when you put an electron between the plates, it's going to experience an electrostatic force that we have labeled Fe. We recall from an earlier chapter that the electrostatic force acting on the charged particle would equal the electric field magnitude multiplied by the charge magnitude. If we divide both sides of this equation by the charge Q, so that it cancels out on the right-hand side, we could see that the magnitude of the electric field is equal to the magnitude of the electric force divided by the charge. I should say the magnitude of the charge. Now the question notes that the magnitude of the electrostatic force was 3.9 times 10 to the minus 15 newtons, so we can plug that in for the electrostatic force. And then since this particle is a charge, the magnitude of the charge is 1.6 times 10 to the minus 19th coulombs. We can simply pick up our calculators and divide these two quantities. And when we do that, we should get approximately 2.4 times 10 to the power of 4. And then we can see from the units that we would have newtons per coulomb. And this would be the correct answer to part A. You could also express that in volts per meter as well. That's an equivalent unit to express electric field. Now on to part B, which asks us to calculate the potential difference between the plates. It's important to note that the electric field that exists between the plates is uniform or constant in magnitude. And in that special case, we can say that the potential difference between the plates is equal to the electric field magnitude multiplied by the distance between the plates. And so now all we have to do to calculate the potential difference between the plates is take that electric field magnitude, which from part A was roughly 2.4 times 10 to the power of 4 volts per meter, and then multiply by the distance that separates the two plates. Now that was given to us as 12 centimeters. We must use the standard unit of meters. So we will multiply the 12 by 10 to the minus 2 to convert it into meters. You can see that the meters will indeed cancel, and that's going to leave us with the unit of volts, which is the exact unit we're looking for. So we can pick up our calculators and multiply, and we get approximately 2.9 times 10 to the power of 3 volts. So this will be the correct answer for part B.